Hello everyone, welcome to the computer vision and machine learning lab using OpenCV. We begin with basic requirements. The basic requirements includes the Python, of course, the key installer, that is a pip. So we begin with OpenCV. First we need to install OpenCV using the pip command in the Python environment. So let us go to the folder. So here we are creating all such experiments. Open the command prompt, and from here we will try to open the Jupyter notebook. So using the command Python notebook. This is the command we use to open the Jupyter notebook from the command prompt. So it is trying to open. It will open through a browser. This is the browser. Now here we can see the created experiment 1, which is for basic operations using the OpenCV notebook. So first we need to install matplotlib, numpy and OpenCV packages. So use the command pip install matplotlib. Since we have already installed, it will show that the requirement already satisfied. Now also the important OpenCV package, that is OpenCV minus Python, is the command to install the OpenCV. So once we install all the required packages, we will download it, we will import into the environment using the command called import CV2. Import CV2 is the command which we use for importing the library CV, which stands for the computer vision library, into the environment. And then we also import the two packages such as numpy and matplotlib packages, which are used for image processing analysis. That is, matplotlib is for displaying the images. If you want to display the images, this is an appropriate package. Now we begin with an image. First we need to read the image. So see here, to read the image, this is the command we use. The command is image equals to cv2.read. Image equals to cv2.read. So this is the sample image 1, which is kept in the working folder where we are running this particular experiment. So here you need to specify the path of the image, the correct address of the image we need to specify, right? So we will convert. See, this image is having 3 channels, so it can be either BGR or RGB. So irrespective of that, OpenCV, the default channels are nothing but BGR, that we convert to RGB, which are compatible with matplotlib. Okay, that is, matplotlib uses RGB channels. So how to convert that? So image RGB equals to cv2 color the image, comma, cv2 color bgr to RGB. This is the command we use to convert the image in cv2 matplotlib format, that is bgr to RGB. Do remember, BGR is the OpenCV default channel configuration, whereas RGB is the default configuration of the matplotlib. Now we will try to see the image. So here, using the matplotlib, we would like to see the image, that is display the image. The command here is So the command here which we use plt.imshow, plt.imshow of image RGB. Of course the access are no matter here because we are displaying an image. Now let us run this and see the image. Yes, this is the image which we are considering for this experiment. Okay, and now we will try to know the shape of the image, that is what are the dimensions, that is nothing but width, height and the channel details of the image. So here we will use the command called, so what is it, height comma width comma channels equals to image dot shape. So this is nothing but multiple assignments. So the image dot shape will give you the details of the size, nothing but height, width and channel details of the image. If we run, you can see the width of the image is 225, height is 225, that is the dimensions of the image are nothing but 225 cross 225. This is the dimension of the image. And how many number of channels are there in the image? You can see that 3. What are the 3 channels? Nothing but RGB or BGR. Okay. Now we will try to resize the image. The original image is with the size of 225 comma 225. Now we will resize the image to 512 cross 512. So here you said that new width as a new variable to 512 and new height as a new variable as 512. Now resize image. Use the command called cv2 resize. cv2 resize. This is your original image, comma new width, comma new height. Okay. Now you can see the dimensions of the original image as well as the resized image. So remember the command used for resizing the image is cv2.resize. So the original image is 225 comma 225, of course 3 channels, and the resized image is with 512 comma 512 size with 3 channels. Okay. So now we will try to look at the or display the resized image. Same, first we need to convert that. Do remember OpenCV uses the format in BGR. Now we are using matplotlib to display the image. So we need to convert that BGR to RGB. So similar to that original image, the resized image also we will try to convert to RGB from BGR. So same command. What is the command? cv2.color BGR to RGB. Okay, so let us run this. Now see this is our resized image. This is your resized image. You can see some change in both height as well as the width. So which is enhanced height as well as the width. Previous one is 225 comma 225. Now this one is 512 comma 512. Okay. Now so this is about displaying the image as well as enhancing the image. Now before we perform several basic operations over the image, we need to convert the colored image. This is of course the colored image. We need to convert the colored image into black and white image. We will convert this colored image into grayscale image in technically. So here is the command we use. What is it? Gray image equals to cv2 dot cvt color. Okay. I want to do some operations over the resized image. Resized image comma cv2 color BGR to gray. Remember the command BGR to gray will give you the image in gray format, gray colored. Still the shape of the image is 512 comma 512 and there are no channels. So if you look at the original image as well as the resized image, you will notice one more coordinate along with your size, along with your width and height. What is it? Number of channels. Here there are no channels in your grayscale image. Simply you will notice that height and width. Okay. Now let us plot this grayscale image. This is your grayscale image. Okay. So how to plot it? Same. Imshow using your what is it? Matplotlib command we will show. We will display the image. That is plt.imshow gray image comma colored map is, what is the colored map here? Grayscale. Okay. So this is your converting the colored image to grayscale image, which is useful for many basic or fundamental operations. Now we will start applying or performing some basic operations over this grayscale image. Okay, so first let us have a blur. Let us see, the original image seems to be very clear. Now we will impose some blur. The blur is nothing but Gaussian blur. Okay, so here we will try to apply two types of blur. One is the Gaussian blur, another one is the median blur. You will clearly notice the difference between the two images, how they look like. So here blurred image, what is it? CV2 dot Gaussian blur of grayscale image 5 comma 5 of 0. So how much amount of blur you want to impose over the image? So which is displayed. Now we apply the Gaussian blur. So this is the result of your Gaussian blur. So you can clearly see the change in the image, the change in the two images, how they look. This one is a blurred image. This is the blurred image. Okay, now similarly we will apply the median blur. So how to apply the median blur? So median blur, CV2 dot median blur of gray image comma 5. That is the amount of blurriness we are going to impose here. The type of blurring is median blur. So let us check this one. This is your median blur. So you can easily compare the two images, how they are. This is your grayscale image, and this is your median blur, and this is your Gaussian blur. Okay, so we wantedly intentionally applying some blurriness. Okay, and next we are going to perform some thresholding over the binary image. So this is the process to apply the thresholding. So this is one more operation that we try to find out. Threshold value is 127. That means the starting point. Okay, 127 is the starting point. Actual range is 0 to 25 is the grayscale range. Now we fix the thresholding level as 127. Of course, it will go up to maximum of 255. Instead of 0 to 255, we make the image range from 127 to 255. Okay, so use the command called cv2.threshold. We try to perform this thresholding over the median blurred image. Comma threshold value, max value, of course it is 255 we said. Starting value is 127. The only difference is previously it is 0 to 255. Now because of the thresholding, the image starts with 127. The maximum value up to it is 255. So if we run this, this is the result of your simple threshold image, how it looks like. Okay, this is your simple binary threshold image. There is the starting point here itself is 127. Similarly, we will apply one more operation, that is the operation is nothing but so we will find adaptive thresholding here. So simple binary threshold is done, and now we will apply. Okay, next one is okay. So so when we have uneven lightening over the image or shadows, non-uniform backgrounds, okay, it is better to go with median blurring, and to reduce the noise. Even if you have the small regions instead of it's a one global value. So what we will do, we are going to perform adaptive thresholding. It's not the thresholding, it is an adaptive threshold. It is useful when the image is with uneven lightening, or if there are any shadows and the backgrounds are non-uniform, then you can perform this adaptive thresholding technique. So here you need to set the adaptive threshold value using cv2.adaptive threshold. Okay, so over the median blurred image only. So adaptive threshold, it's a method of the mean neighborhood. Okay, and threshold binary of maximum value 255. Okay, so adaptive threshold will consider the block size, nothing but the size of neighborhood as 11, right, and the constant subtracted value will be the 2. So if we look at this adaptive thresholding, This is your adaptive thresholding, which we are getting from this adaptive thresholding technique. Okay. So, and the last one, adaptive Gaussian. Adaptive Gaussian technique, same thing. We will apply over the adaptive Gaussian. So, which will be your adaptive Gaussian thresholding technique. The result of your adaptive Gaussian thresholding technique you can notice. And similarly, the third one is the combination of both. Okay. So, nothing but the method which is optimal and global threshold value automatically by minimizing the intra-class variance, and it is very perfect for bimodal histogram images with a clear foreground as well as a background. So these thresholding technique, you know that we are going to set the minimum value, and we are going to have the adaptive thresholding technique for uneven images, uneven backgrounds or uneven lightnings. We can go with this. So this is your Woods method that will reduce the noise. So this uneven lightning or uneven backgrounds are still treated as a noise here. So this is your resultant Woods technique. So this is your this is the outcome of your technique. See here, right? So in this video session, we have seen how to begin the image processing operations using the OpenCV library with the help of the NumPy as well as your Matplotlib. Matplotlib is the tool to display the images. NumPy is to see the to perform the numerical operations such as size or reshape, resizing. We use the NumPy, and we are able to read the image. We are able to resize the image. We are able to convert from color to grayscale image, and we are able to perform some blurring, nothing but the Gaussian blur and median blur, and we are able to perform some thresholding techniques, right? So this is the session for today. Thank you.